Okay, so what's the best estimate for f prime 4 we can make based on this table? So f prime 4 is the derivative when x equals 4 of the function f. So we're trying to estimate the derivative when x equals 4. And we can do this when we're given a table by seeing where the 4 would go. So the 4 would go in the middle of 3 and 5. And we know that a derivative is an instantaneous rate of change. So we had to find the rate of change at 4. So to do this, we have to find the slope from 3 to 5, because that would estimate what the rate of change is when x equals 4. So to find the slope when x is 3 and when x is 5, we would have to do y2 minus y1 all over x2 minus x1. So in other words, that's f of 5 minus f of 3 all over 5 minus 3. And that's a good estimate for f prime 4. Let's give a approximate. Okay, so f of 5 is 112, f of 3 95. So 112 minus 95, that's 17. 17 all over 5 minus 3 is 2. And that would give us 8.5. So f prime 4 is approximately 8.5 according to this table, because 4 falls between 3 and 5. And we basically found the slope based on the points 3, 95 and 5, 112. Okay, good. What's the best estimate of g prime of 18 that we can make based on this table? Okay, in this example, where does 18 fall in between? Okay, it falls in between 16 and 19. So g prime of 18, it's the, when x equals 18, this is the instantaneous rate of change. So to estimate that, we would basically find the slope when x is 16 and when using the points when x is 16 and when x is 19, because that would be in the correct range when x is 18, and it would be a really good way to estimate what g prime of 18 is. So g prime of 18 is approximately, hold up, sorry, yeah, so g prime of 18 is approximately g prime of 19 minus g prime of 16 all over 19 minus 16. This is basically the slope. That's the best estimator of a derivative when we're only given a table like this. So g prime of 19 is 96, g prime of 16 is 87, 96 minus 87 is 9, and 19 minus 16 is 3, so 9 over 3 is 3. So g prime of 18 is approximately 3. What is the best estimate for f of f prime 2 we can make based on this table? Okay, so 2 is in between 1 and 4. So we would use the points 1 comma negative 25 and 4 comma negative 33. And the derivative in this context is when x equals 2, what's the instantaneous rate of change of the differentiable function f? And to estimate that, we would use these 2 points. We would find the slope of it, and that's the good estimate for the derivative or f prime of 2. So we would do f of 4 minus f of 1 all over 4 minus 1. So f of 4, negative 33, minus f of 1, negative 25. So negative 33 minus negative 25, that's negative 8 all over 4 minus 1, which is 3. So that's negative 8 all over 3, and that would be approximately negative 2.67. So f prime of 2 is approximately negative 2.67 according to this table. What's the best estimate for h prime of 18 we can make based on this table? Okay, so negative 18 is in between negative 20 and negative 17. So when we're predicting it, when we're predicting h prime of negative 18, we would use negative 20 comma 5 and negative 17 comma 22, and we would try to find the slope between both of those points, and that will be a really good estimate of what h prime of negative 18 would be, or the derivative when x equals negative 18 for the differentiable function h. So for this example, we would do h of negative 17 minus h of negative 20 all over negative 17 minus negative 20. So h of negative 17 is 22 minus h of negative 20, which is 5. So 22 minus 5 is 17. 17 all over negative 17 minus negative 20, which is 3. 17 all over 3. And that is 5.67 approximately. So that's the best estimate of h prime of negative 18 we can make based on this table. So remember, when doing problems like these, you basically have to find the slope because that's the best estimate for a derivative when only given a table of values like these. And try to find 2 points that contains the x value that we're being asked for. So for this example, when we're being asked for negative 18, the derivative at when x equals that, we would go in between negative 20 and negative 17. So when you're doing problems like these, get a point that kind of makes the point being asked fit in between both of those. So let's check the answer. Okay,